Hello, and thank you for joining me. You're here with Data Science Teacher, and we're going to go over the K-Neighbors Classifier today. Okay, so we'll start with the importing our data science libraries. We're going to import a couple things for plotting specifically, so plotly express, SPX, and plotly graph objects as Go. Graph objects, we're not doing anything super complicated. I wanted to add something to the regular plotly plot, so I needed the graph objects to be able to do that. We're going to look at K-neighbors. We're going to look at what happens when we put K-neighbors inside of a bagging classifier and then just confusion matrix to see how it's going. Standard scalar and train test splits. Very important. And then turning up the water since we wants to see that. Okay, so what we're going to do, this is going to be a really challenging prediction, which I think it better demonstrates what works well and what doesn't work and how these models work if we have make a really challenging prediction. So what we're going to do is we're going to try to predict which penguin in our penguin data set is which island they're from. So imagine a penguin rolls up to her boat and we need to put it back on the right island. We now have, well, hopefully have a model that works well and we're able to figure out where that penguin belongs. Okay, so pretty challenging prediction. Okay, so just a quick little EDA to give us a sense of the data set here and pre-processing. Not really too much to do. I filled a couple of the null values to the median, and then when it was the sex, I filled it with the mode. Okay, right there. And then one hot encoding, sex and species. So we're going to use both of those because we're not predicting either one of those. We'll use those, the sex and the species, to see if we can help predict which island the penguin is from, our lost little stranded penguin is from. Okay. Putting them into the features and target list, putting it into the X and Y, doing a train test split here. For demonstration purposes, I didn't end up using my standard scalar just because, well, for plotting, and you'll see it makes a little bit of sense. You would do this in a real prediction, but just in this demonstration type class, I didn't do this. If you wanted to do this, you could do this, but just make sure that everything will work. You just have to re-add back the titles to the train and the test, and everything will work the same going down. I wanted to see really how irrelevant of getting everything standardized. I want to just really see how the data was, but we can look at the classes and look at the centroid further down. Okay. So just looking at using it in the most basic form. Okay, so K-neighbors classifier dot fit, fitting it, initializing our model and fitting it at the same time, get a score of 76 and 69. That's the question. Well, we didn't choose the number of clusters. So let's iterate through this and build a list of the number of clusters. Here, what I'm going to try is from 2 clusters up to 15, but not including 15, so 2 to 14. Make a list of my train test score, for cluster in clusters. I'm going to train my k-neighbors with each one of those clusters. Okay, doing the train to test score, but appending it to the list this time, putting the list into a dictionary, train score, test score, putting that into a data frame. Dictionaries fit really nicely into a data frame. And just showing here, I did clusters and I got the test score, the best test score, looking at the test side, np.argmax, which returns the index position of a list. And then if you put that into another list right here, it'll pull out the value that was the highest one we're concerned about. So here we can see that the highest was 5, and that comes up right here. And I added this to the title just to make it a little bit more cleaner and easier to plot. Okay, so, or in our visualization. sklearn SNS.heatmap, the dictionary from above, a note, CMap blue, and then line width equals 1, just a little bit of spacing between those. Adding the plot right here. Just notice I'm putting a line break before and after just to add a little space in my title right here. And so we got 5. So we got relatively easy scores. There's a lot of overfitting. We're not going to go into depth in overfitting today because that is just, we get lost talking about that. So we're going to leave it as is. Oh, there's obviously a large amount of overfitting going on, and there would be a lot that we could do, not specifically with the k-neighbors, but we could do a lot of pre-processing to try and prevent this from happening. There might be some overfitting specifically with this data set, though, that we cannot prevent. And again, but we're not going to talk a lot about fitting today, but just noticing that it is there. We really want to look at how the k-neighbors works more so. Okay, so we got the best test score right here, 62, but notice that quite a few of them do well as well. It wasn't as significantly better. It is better at 5, but not significantly so. Not significantly different for each one of these. Yeah. Putting my KNeighbors in here. So I got 5 as my best one. Predict with that, get my score. I'm going to save that. And then what I'm going to do is look at my confusion matrix. So if I look at my confusion matrix, here we get our confusion matrix, plt.figure. I'm going to set the scale, font scale to be a little bit bigger so I can see this. Heat map, confusion matrix, a note, format D, which just makes it digits and makes it a little bit nice and cleaner. You don't need decimal place in this. And just doing a light palette, square, tick labels, no C bar, no color bar, and a noting the size again of these to be a little bit bigger. Okay. And then changing label and adding a title. Okay, so we can see we're missing the one class, I believe, is Torgan, which we don't have a lot of representation of. So we're missing quite a few. We're not doing good at predicting this, basically. And that's one of the reasons for the poor score that we're seeing. We kind of overpredict these classes that we see represented more often. That could be something we fix in just the sampling that we do up above to fix this overfitting problem. Okay. The KNeighbors with bags. This is really likely the way that you would use this in practice. Sometimes, very rarely, the KNeighbors works really well by itself. It works a lot better using inside a bagging classifier. So we're going to set the KNeighbors equal to 5 neighbors inside as the base estimator of the bagging classifier. So we're going to get the bootstrap aggregated resampling. We're going to take 80% of the rows, build a model, take another 80%, build a model, take another 80%, build a model. So instead of a decision tree inside of this, you now have a kind of like a random forest, but a random forest of KNeighbors classifiers. Okay, and this it does really well. It holds really true to the ensemble method and why those work well. Okay, predicting and getting the score of both of those as well. Okay, and then looking at our decision maker, we're still really overfitting here. And not predicting well on this one class, although a slight improvement in the overall score for sure. Okay. So visualization of the centroids. This is kind of one of the cooler things that we could look at. Okay, and so now we're going to visualize the centroids. So here what I'm doing is I'm just predicting from the bagging classifier, the series right here, putting it into a series so that I can put it into the Y prediction into pd.concat, stick it with X test right here. I'll need the values of the rows right here along with the targets. I'm going to put everything back into the same data frame called test here. Okay, and we're doing it across axis 1, so we're sticking them together horizontally. Building a list of my features that I want to use, so build length, build flipper length, and body maps. Classes right here, and just getting a list of my classes that we're going to use in our data set, the ones that we had available. And then I'm going to go centroids. Okay, it's building a blank list. This is a little bit of a confusing loop, so I'll go through this quickly. So df centroids, building a blank list that we're going to, or blank data frame that we're going to fill. For C in classes, we're going to make, every time I'm going to make a blank data or blank dictionary, then I'm going to then use pd.concat to stick them kind of together, put it in a data frame and then stick them together. So making that blank dictionary to start for this little section. In this section, so after for every class, what I'm going to do is then loop through each feature and we get the mean of the feature, and I'm going to put the mean into a dictionary. So I'm going to take it to the mean of that class, what's equal to that. I'm taking the new column that we added of the predictions that we got. Okay, so when that's equal to C, so we're looking at really the centroids of the predictions, okay, to get where the centroid would be. Okay, and then dic centroids and adding the mean to that value. And then I'm going to put the dictionary, and then I'm going to add the prediction class to the dictionary as well so that I have it in my final dictionary. You can see how it printed as it looks like right here. And then what I'm going to do is when I put that into a data frame, I'm going to essentially make one row at a time. You can see all the indexes were zeros. Here you just have to put an index if you're only one value. I'm just putting them in. And then we're going to go df centroid pd.concat and stick each data frame, dictionary, well, kind of a data frame of one row, and then stick them together with the same labels, or feature names. Okay, so we're going to have this now. We have a list of where the centroids are for each one of these based on the predictions. I'm making a little list of colors so that we can have this in the final plot. And this is a little bit not super complicated. If you're new to plotting, this will be a little bit tricky. I have to use the more advanced version of Plotly, not just a simple express to get this to work, mainly to plot the centroids afterwards. So let's just go through this quickly. Okay, so I make a figure, I'm adding the traces, which means I'm going to add in a go scatter plot, go 3D scatter plot, and I'm going to make a test. I'm only going to plot it each time for each one of the labels at a time. Okay, I'm going to say the label is equal to the label of my classes, which is the list that I made up right here. Okay, and so every time we loop through that, we're going to go test, and we're going to select that, only those rows from the data frame, and then plot those, and then do that again, and then do that again, and then do it again for each one of the classes. Okay. And then symbols, just going to be circles for this one, mode markers, and I'm not clusters, just making the name of the label, and each one of those. And so bill length, flipper length, body mass. Okay. To plot it in three, because we're going to be plotting in 3 dimensions today. Okay. So that right there was making the, so first make the blue, the green, and then the red dots right there. Not so many red dots right there. And that's why we were really overfitting or kind of underfitting, not predicting this well for the red dots, because we really don't have a lot of, we're not really represented. This is looking at the test set, so it's much smaller, but we're not really represented in a huge amount for the Torgensen class. Okay? And that's why we were bad at predicting that. Okay, what I'm going to do here is I'm going to, after I enumerate for that and I make my scatter, then what I want to do is make my centroid. Okay, and so from the data frame that I just made up here, what I'm going to do is do the same thing. I'm going to go for I and labels, iterate through that. I'm going to add the trace to go 3D scatter. And what I'm going to do this time is the special thing that I'm going to do is make the markers a circle open. And there's really nothing actually different that I did here, truthfully. And so this is logically indexing, selecting it based on the label, each one of the labels, and that's why I included the label right here. And really, again, we're just plotting three values. There's one row right here, so it's not really, it's just one dot. It's a centroid. And so plotting that one row right here of the bill length, flipper length, and body mass, markers, centroid label, and then symbol open circle, circle open, color, and I'm iterating through that list of colors that I had, blue, red, green, and I'm going to do a size of 35. And then just quickly doing final little touch this to add a little title right here, and then add add the label names, body mass, bill length, and flipper length here. And we get a pretty cool plot here. Now you can see here we're able to really inspect this, and pretty obvious that we have this one blue cluster, which is the Bisco, and it's labeled right here pretty centralized or pretty off by itself. I think it would be pretty easy to classify this one. Although you can see our predictions still were over here, and we were still able to predict those as one class. Our green centroid right here is focused around, centered around this class right here. You can see we have the green right here. It's centered right in the middle of that, and then the red is centered right in the middle of that. And this just allows us a lot of ability. Let's say I didn't want to look at the red for a second. We can really see what's going on between these two and get a better sense of the data. At least see where it is. And I think it would be, getting a lot more detail than you would normally do or you would normally get here. And so we can really inspect this and start to get a true understanding of really where the centroid is. And I think it just makes a really cool visualization plot to show really where the centroid would be. You have the coordinates of the centroid, but it'd be a little bit better just to kind of plot and understand exactly what these are. The 3D scatter plot is just a really cool tool to be able to do this and look at our centroids and our clusters that are using the predictions here. The clusters or in our KNeighbors classifier. So thank you so much for joining me today, and I will see you next time.